Hello everyone, let's go ahead and take a look at number sequences. A sequence is a list of numbers where there is a pattern which generates the list. Now if we go ahead and take a look at this example, 36, 31, 26, 21, and dot dot dot, where the dot 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 means that the list continues on forever in that pattern, then we can definitely see that there's going to be a particular pattern to that, and therefore we can call that a sequence. Now the members of the sequence are going to be called the terms of the sequence. So this is one of the terms, this is the other term, this is the third term, that's the fourth term. And notice that what we're going to do is we're going to associate it with where it is in the particular sequence. So in other words, this is going to be the first term, second term, third term, fourth term. Okay? Now what we're going to do is we're going to introduce some mathematical notation. It's going to be very, very important that you remember what this notation represents, as well as how to say it. So I'm going to go ahead and associate this particular term, which is the first term of this particular sequence, as u sub 1. And the u is going to generally represent a sequence. So u sub 1 represents the first term of the sequence, and that's going to be equal to 36. So what we say is that u sub 1 equals 36. In the same fashion, u sub 2 is equal to 31, u sub 3 is equal to 26, u sub 4 is equal to 21, and we could go on forever. So what we want to do then is we also want to be able to go ahead and express sequences. Now, how do we go about doing that? There's four particular ways in which we can do that. One, we can express it using words, or we can use an algebraic formula, or we can go ahead and express the sequence in a table form, or actually taking a look at it in its graphical form as well. So let's just take a look at this particular example and see how we can go ahead and use words to go ahead and express what this sequence is. So what we could basically start off with is say, well, this sequence starts with 36, and then we subtract 5 for each subsequent term. So if I start off with 36, I subtract 5, I get 31. If I subtract 5, I get 26, etc., etc. Now, if we wanted to use an algebraic formula, I could go ahead and express u sub n as 41 minus 5n, where n is going to be an element of the positive integers. Now, remember that n is going to represent this number, which then goes ahead and tells us which position the term is. So, for example, if I substituted a 1 for an n, which means that I'm talking about the first term, then u sub 1 is going to be 41 minus 5 times 1, which of course is going to be 36. So notice that this algebraic formula here is actually going to generate this sequence for us, and we can then go ahead and find out any particular term just by substituting a particular integer, positive integer value for n. Now we'll go ahead and take a look a little bit more in depth as to how to go about generating these formulas, but at least as an introduction, this is what those formulas will look like. Now again, we can also go ahead and use a table. So notice again what I have here is I have the value of n, and we said that n is going to be a positive integer. So notice the n values start with 1, 2, 3, 4, and of course we could continue if we wanted to. And then notice that the u sub n value for u sub 1 is equal to 36, u sub 2 is equal to 31, and therefore it's going to be consistent with the information that we have there. Now the last way that we want to take a look at is the graphical form. Now notice, usually when we talk about a graph in 2 dimensions, we usually talk about the x-axis and the y-axis. Now in this particular case here, we're going to be taking a look at the n value, right, the n-axis right over here, which is the horizontal axis. And that particular n value will then go ahead and generate a particular u sub n value. So if I was to go ahead and just take, say for example, the values that I have here in this table, and I was to go ahead and plot it using a graph, this is what the graph would look like. Notice I have 1, 36, 2, 31, 3, 26, and 4, 21. Again, which is consistent with this information that we have there. Okay, so let's kind of recap. Remember again, a sequence is a list of numbers where there is a pattern which generates the list. All the terms, or all the members of the sequence are going to be called terms of the sequence. And the notation is going to be very important to become familiar with. Now there's 4 ways that we can go ahead and express sequences. We can use words, use a formula, use a table, or use a graph. Okay, so we'll go ahead and take a look at some examples the next time that we're in class. See you then. Bye-bye.